So we're going to try 3 trickier problems that we've got here. This first problem that we've got, there's a question really similar to it in exercise 6A, and there's one from the mixed exercise that is quite similar, and I'm going to want you to try these in a minute or as homework. So I've got this picture of a spinner here with 2 reds and 3 blues, and it says this spinner is spun until it lands on red or has been spun 4 times in total. Find the probability distribution of the random variable S, the number of times the spinner is spun. So this is quite complicated because it's not a straightforward game anymore. It doesn't just say what's the probability that it's on red or what's the probability it's on blue, but we've actually got something that's now saying the spinner is spun until it lands on red or has been spun 4 times in total. So let's think of the options that we could have. What's probably the way that the game ends quickest? What would happen? First time red. So one of the options could just be it lands on red. What about if it was only going to be spun twice? It would be blue, then it would be red. What else is there as an option? Blue, blue, red. Blue, blue, red. Blue, 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 red. What do you mean nothing? 4 blues. So you could have blue, 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 blue. So we've got all of these different options here. But remember, the random variable S is the number of times that the spinner is spun. So in this first case that we've got here, this is where S is equal to 1. The spinner is being spun once. The spinner is being spun twice. The spinner is being spun 3 times here. And these two both represent the spinner being spun 4 times. So we now need to come up with the probabilities of all of these different things that are happening. Do you see how the best way to start this off was not to try and dive straight into the problem, but to think, what are the possible things that could happen? This is what we call a sample space. Whatever you want to do to try and visualize how this game or how this particular experiment is going to play out. So previously we've been doing them all with X. This time they've asked us to use the letter S. So we're going to have our table that's going to have an S, little s, and the probability that the random variable is equal to that little s. And so the options that we've got, it's either going to be spun once, twice, 3 times, or 4 times. So some of these are going to be pretty easy to fill in. What is the probability that the spinner is only going to be spun once and then it's game over? Pardon? 2 over 5, because that's it just landing on a red. So the probability of this first one, of it just being a red, is just 2/5. So that's a really easy one. It's just going to be 2/5. Now I'm going to talk about the probability that I get a blue and then a red. When you're doing probabilities of something and something, timesing, good. So probability of blue is 3/5, probability of red is 2/5. So it's going to be 3/5 for the blue and 2/5 for the red, which is, hello, anyone? 6 over 10? 6 over 25. Goodness me. 6 over 25. Yeah, stressing me out there. Okay, blue, blue, red. So we're going to do blue, blue, red. Blue, blue, red. Oh, anyone think they can calculate that and get it right? 12? Where'd you get 12 from? 18 over 125. Can that be simplified? 18 over 125. No, it can't. No, it can't. Now, pardon? 18 over 125 can't be simplified. Nope. So I'm going to put that here as 18 over 125. Now, there's 2 things I could do. One of them is long, one of them is short. What's the short way of finding out what the last probability is? Add them all together and take it away from 1. Because I know that all 4 of these things have to add up to 1. So I could, on my calculator, I'm just going to do, to find this one quickly, I'm going to do 1 minus 2/5, 6/25, and 18 over 125. I'm going to do the quick way, and I'll tell you the other way how you could do it. That calculator has now finally lost its batteries, so let's try this one. So 1 minus 2 fifths minus 6 25ths minus 18 over 125. I get the answer, what do I get? 27 over 125. So the other way of checking it, though, would be to do what? So what would be the other way of doing this? To do blue, blue, blue times red. In fact, I'm going to be a bit quicker. I'm going to do blue, 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 3/5 cubed times by red. And I'll do blue, 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 which is 3/5 to the power of 4. So that's 3/5 cubed times 2/5. And that is 54 over 625. How much?
81.
Yep.
625.
81 out of 625. So then how have they got 27 out of 125 from these?
Did they subtract?
No, they didn't subtract them. What would they do with these two probabilities? Because it's either this one or this one. No, not multiplying. That's if they and happen. You combine them, you add them together. So if you add these together, if you do 54 over 625 plus 81 over 625, you do get 27 over 125. With probability, if it's an and, you multiply. If it's or, it's add. Because I'm saying you can either get it this way or this way. So you add those two combos together to get that probability. But I'm sure you'll agree, this was the shortcut of coming up with that probability for that distribution that we've got there. Okay? They all add up to 1. Those are the only possible ways that we can have that. So if you'd like to practice one of these in a moment, exercise 6A, question 11 is like that. Also from the mixed exercise 6, question 6 is also that kind of style. We're going to do 2 more questions that test a few different kind of problem solving, and then I'll show you what we'll do next with it. Has everyone got all this written down that they want? I'll come back to it at the end if you need to finish it, yeah? You're done? Okay, good. So this one, it's an exam question, so you can see it's written in that different kind of font that we've got there. It says, a biased spinner can only land on one of the numbers 1, 2, 3, or 4. Because it's a biased spinner, we know it's not a discrete uniform distribution because the probabilities are not going to be equal for each of them. The random variable x represents the number that the spinner lands on after a single spin. And probability that x equals r equals the probability that x equals r plus 2 for r equals 1, 2. Well, they've tried to make that sound as absolutely confusing as possible by showing us things that we probably feel are a bit unfamiliar. We're just going to try and figure out what those things actually mean and then come up with the distribution. So r is kind of like the little x in this case that we've got here. And it wants us to find the complete probability distribution of x. Well, first of all, what numbers should I put in place for x? What options can I get for the outcome?
1 and 2.
No, there's more. 1, 2, 3, and 4. And they've told us the probability that x is equal to 2 is 0.35. Let's have a look at this thing that they've said. They've said the probability that x equals r is equal to the probability that x equals r plus 2, and that's true for r equals 1 and r equals 2. So what should I do with this information that I've got here?
0.35 for 1 as well.
Yeah, because this, if I substitute 1 in, I get the probability that x equals 1. Not quite sure if that's actually true what you said there. Is the same that probability that x is equal to? No? 3. 1 plus 2 is 3.
So that means 3 would be 0.35.
So when r is 2, the probability that x equals 2 is the probability that x equals 4. So that means that this one and this one must be the same probability as each other. So this is 0.35. And we know that these two, from this sentence here, are also the same as each other. So these must be, you do 1 minus the 0.7 of these two, which is 0.3, and half of 0.3 is 0.15. So it's actually not that difficult a question, but I think what's hard about the question is that they decided to give this like weird language at this point that we've got here. The reason I've crossed out this part here is because it's like the second half of this chapter. We haven't learnt enough stuff at this point to be able to do that bit, but we'll learn about it later on. Then we've got, for part C of the question, it says something weird. The random variable y equals 12 divided by x. Find the probability that y minus x is greater than or equal to 4. So they've told me this, and I've got this here. I've got those two things I've highlighted in yellow. I know absolutely everything about x. I don't know anything about y. So what do you think I should do with these two things that I've highlighted in yellow if I know about x and I don't know about y? Good. I'm going to substitute them in. I'm going to try and get rid of y so that my whole thing is to do with x. If it's all to do with x, then I can just get on with the question. So instead of doing y minus x is less than or equal to 4, I'm going to replace the y with 12 over x minus x is less than or equal to 4. I'm going to keep manipulating this inequality that we've got here. What could I do to this inequality to change it? Because I don't like having a divide by x here. Times everything in there by x. So I'm going to multiply everything by x, which will then give me 12 minus x squared is less than or equal to. It becomes a quadratic inequality. Okay? So I'm going to rearrange this so it looks like a normal quadratic. So I have x squared plus 4x minus 12. Anyone see how this factorizes? Minus 2 and plus 6. Minus 2 and plus 6. Remember, for a quadratic, you should do a quick sketch of what it's going to look like. So that means it's crossing at minus 6 and positive 2. So the solutions to this, I've probably run out of space. Hopefully you've got a bit of space on your page. The solutions are that, well, what should the quadratic solution be for this inequality? Either x is, but we're looking for when it's greater than 0. So we're looking at this section here and this section here. So
You mean 6 and minus 2?
no, I mean minus, it's because when you solve this, the place where it crosses is at 2 and minus 6. So good. Either x is greater than or equal to 2, or x is less than or equal to minus 6. So this thing that they asked us about at the beginning, the probability that y minus x is greater than 4, is actually the same as the probability that x is greater than or equal to 2 and the probability that x is less than or equal to minus 6. So we had to change it from whatever the thing was to begin with. We've had to change it into an inequality that we can actually use. So to finish this off, the probability that x is greater than or equal to 2 is what from here? What's the probability that x is greater than or equal to 2 for this game? 0.85. 0.35, 0.15, 0.35. It's those three values there added together, which is 0.85. What's the probability then that x is less than or equal to minus 6? It's impossible for it to be less than minus 6. There's nothing in here that is less than minus 6.
You said it's an and. They can be an and times by together, right?
No, I don't want it to be both of them true at the same time, because this inequality here is actually, this is an or one. So I'm just saying, so the probability that y minus x is less than or equal to 4 is 0.85. So they've just been really annoying and they've asked us lots of things all together. What they've actually asked you to do is simultaneous equations that gives you a quadratic inequality that then you can use the distributions with. you can add the probabilities together. So there's nothing new, but I wanted to show it to you so it didn't feel unfamiliar if you ever came across something that looks like that. So we're going to do one more question together, and then we should have about 20 minutes to do some practice together as well. Everyone got that down? Nearly? So the key thing here was you had these bits in yellow to begin with, and because we knew nothing at all about y, we had to combine them and get rid of y so that we could do it in terms of x, because we know everything about x. We didn't know anything at all about y, so we had to make it all about x. And then the last one that I've picked, I can come back to this page in a second. I just want to make sure that we've got time to do this. So if you need it at the end, I'll put it back up for you to copy, okay? The last one I've put here is one that's really wordy. And the reason I've made it I picked a wordy one is because it's going to help us think about games and how people win in these games. They've started to put questions in that are a bit like this, so I want to see if we can nail this one. This time it says, a spinner is designed so that the score, S, is given by the following probability distribution. Find the value of P. So that's a pretty quick one to find out what the value of P should be. 0.1, because these add up to 0.5. That makes it 0.7. That makes it 0.9. So the probability of P here is just 0.1. Nice, easy question for that first bit. It shouldn't be in the old. This is from an old question. This would be worth 2 marks in the old. This would only be worth 1 mark in the new specification. Okay? Tom and Jess play a game with the spinner. The spinner is spun repeatedly, and S counters are awarded on the outcome of each spin. If S is even, then Tom receives the counters. And if S is odd, then Jess receives them. The first player to collect 10 or more counters is the winner. Find the probability that Jess wins after 2 spins. Well, first of all, I think we should just remind ourselves about how this game works. So they're going to keep spinning it, and they're going to get the same number of counters as whatever it says along the top of it here. It says, if S is even, then Tom wins. So I'm going to highlight the times that Tom would win the counters. He would get the 2, and he would get the 4. Technically, 0 is an even number as well, but he wouldn't win any counters. So it doesn't really matter either way. And Jess wins if S is odd. So Jess is going to win either 1 counter or 5 counters that we've got here. And we want to find the probability that Jess wins after 2 spins. Well, the way that you win this game is you collect 10 or more counters to become the winner. So how is Jess, but I've skipped out some parts for this question, which is why it suddenly goes from A to E. So how is Jess going to win? So the probability that Jess wins after 2 games, she has to get a 5, and she has to get a 5. Yep? It does count as even, yes, although it won't matter in this game because 0 doesn't give you any counters anyway, but 0 is an even number.
0.4.
So it would be, it would be 0.2 times 0.2, which is 0.04. So she's only got a 4% chance of winning it in 2 goes. Now we want to find the probability that Tom wins after exactly 3 spins. So how can Tom win the game?
So he needs 2 4s and 1 2.
So he needs 2 4s and a 2.
Or can he also do 3 4s?
Or he could get 3 4s, couldn't he? Because you can get more than 10. So find the probability that Tom wins after exactly 3 spins. So he could get a 4, a 4, and a 2.
You can get 4 4 4.
Or he could get 4 4 4. But I've left a couple of gaps here. Why have I left some gaps here? Because they could be in any order. He doesn't have to get 4, then 2. It's different to him getting 4, 2, 4. And it's different to him getting 2, 4, 4. So there are 3 of these ones and 1 of these. So one of these would be 4, 4, 2. It would be a 4, a 4, and a 2. So it would be 8. That's for the 2 4s. That's for the 2. And I'm going to multiply it by 3 to represent that there are 3 different outcomes that he could do to come up with that. And then this one is a 4 times 4 times 4. Sorry, a 0.2 times 0.2 times 0.2. So we'll come up with these probabilities and see what we get. So we have 0.2 times 0.2 times 0.25 times 3. So this is 0.03. And 0.2 cubed
1 over 125.
is 1 over 125, or 0.008. So the probability that Tom wins after 3 is going to be these two things added together, which is 0.038. So we're going to do the last one now. We want to find out what is the probability that Jess wins after exactly 3 spins.
I for 1.
Jess, though.
Oh no, you mixed it with 4.
So how could Jess win?
115.
She could get... Would she even win after 115? She wouldn't have enough points. She needs to win...
If she gets 5, 5, she won in 2 rounds.
5, 5, 1.
Okay, so she could get... But I don't think she could do 551 because she would have won already.
155.
No, but that's the same thing as that one. 4, 4, 4.
Yeah, but he doesn't win after 2. She wins after 2 because that's 10 points. So you can't have 551 because she would have already won at that. She would have already got 10 points.
5, 4.
So
155.
why don't we... So she could either get a 5 and then it has to just be something that is not a 5.
That's impossible. No, she get 1 and she get 5 again. She get 1.
She could, okay, fine. So she could get a 5 and then a 1 and then a 5. 155.
Yeah, because you get 5, 1, 1.
But that's 4 spins if it's 5115. We're saying about how she's going to win after exactly 3 spins. But what about if it was a 5 and then Tom won and then she won? Or what about if Tom got a 0 and then it was 5 and then a 5? Yeah, but that doesn't stop her. That doesn't stop her winning. She just needs to get 10 points. So I don't think.
You have to take into consideration all.
Okay, so it feels like it's going to be really long because we need to take into consideration all of them. But I think there must be a better way of us thinking about this. So instead of it being 515, because it could be 525, or it could be 505, or it could be 545. What do you think, Andrew? No. We don't want to make this too complicated. All we're going to say is this. In fact, let's keep that last bit there. Let's say that it's going to be that she gets a 5, then she does not get a 5, which I'm going to do with the 5 with like a line above it, or a 5 with a dash, because you know the dash notation means not. So it could be a 5, not 5, and then a 5. Or it could be a not 5, a 5, and a 5. I don't care. When it says not 5 here, 5 dash means anything but 5. Does that make sense? If it's anything but 5, she won't get enough points. Because it could be like 5, 1, 5, it could be 5, anything 5. So 5, not 5, 5, that probability is 0.2. So that's 0.2 multiplied by, what's not 5 going to be? Anything, what's anything but 5? 0. Who said that? 0.8. The probability of 5 is 0.2. The probability it's not a 5 is 0.8. So it's 0.2 times 0.8 times 0.2. And this one is not 5 times 5 times the 5. In other words, these things here are 2 lots of 0.2 squared times 0.8. And the probability is 0.064. So it's a tricky question, but you've always got to try and find the simplest ways of going about these. So we have only got about 15 minutes. We're going to try some of these questions that I've printed for you in your booklets that say extra questions. What I'm going to do, in case you're looking back at this, these are all obviously on the Google Drive, but the questions are these ones here. So we're going to go through these. We'll do these on the whiteboards, but I'm just going to quickly go through them and put the mark schemes. I've got rid of some of the questions, the answers in the mark scheme because they don't apply to us. So these middle bits we don't need either. And then last one. Okay, so I'll leave it on this one here. Let's go.